Hi, this is chapter 24, ANOVA analysis. So at the bottom of the notes, you probably noticed the first video will give us a more detailed explanation of how to do the ANOVA analysis. Use this example, Analgesics. And the next video, we will try to do the this example in Excel. So first review this video, and then we go to the ANOVA analysis in Excel. Let's take a look of. So this is the Analgesics sample data. You probably see we already copied the sample data. We have 4 data for each drug. So it should be drug A, drug B, drug C. I use sample A, B, C here. It's just for general name. And then we have the let's take a look at original data. So from original data, we have pen level and the drug formulation, and we can see there's 4 pen level data values for drug A, 4 value for drug B, 4 value for drug C. Just separate them their own columns. So this one for ANOVA analyze. As we talked about before, we have the data analyze tools. I'll go to data analyze tool. And the first one is ANOVA single factor analysis. This is the only one we cover for our course. So choose this one. Okay, and then it will first, the input range, we want to select all this range. Just select all the data here. All the data are selected in this cell. And then the grouped, so we need to see the grouped data is a column, in column. And then labels in first row, also check this one. Alpha level 0.05. We only do ANOVA analyze in 0.05 for this course, so always 0.05. And output range, later on we'll talk about how we determine this one. And here we probably use any, you just select any points and then click OK. So you see, this is the ANOVA single factor analysis. So basically we have drug A, drug B, drug C, and then count. So we have 4 for each group. And then basically this one is the same as we using other software, statistical software. We would get these tables. And this one is basically give us the sum of the square of the variance, the degree of freedom. This is between groups and within groups. And then this is the mean squared variance. And remember how to get this F value. See the first video introducing how we get this F value. And then the P value. So in this course, we always determine our hypothesis result based on the p-value rather than the critical f value or critical other t or z test value. So this p-value 0.000, it's really in some cases we see this value is close to 0. The next way, that's basically we want to see there's several assumptions like random, independent select samples, and we do need, so that's these 3 sets of data. This is the box plots. So that's if we choose this one. So that's basically we will do the box plots, and from box plots we can see this is the drug C. It's quite symmetric. The data is quite symmetric. And drug B, that's this one is a little bit skewed to negative. And this one also has a negative skewness. So we do, remember we do some tests. So before we do the normality test, we go to, so you probably see this is not all the value we want to answer the ANOVA questions. Let's take a look at the templates. So this is the ANOVA test templates. It not only include the ANOVA test, but also the two keys test. So two keys test, that's basically once we see if there is yes, we have a difference between the means, and then we want more details, which one is different or which are the same, similar results. So that's two keys pairwise test. So for this question, we same thing, we just copy this data into our templates. So put over here, Control V. So you probably see some values. So in the templates, this columns is not included. You have to calculate this one. Later on we do the normality test on the residue. We need to calculate that one. And continue, we just use the data analyze tools. So you need this one. Same thing, we do the input range. We want to get the input range here. It's also grouped by columns, label in the first row, alpha level 0.05. You probably notice this cell is highlighted. So output range, we need to select this one, exactly the same cell. That's basically the value in this table will affect our calculation below. So we want to select this one. Make sure you select this one. Okay. So this is basically the same result as we see before. The only thing is now we want to see the two keys pairwise test. So we know because the p-value is so small, we say we reject the null hypothesis. That means the all means are equal. That assumption is rejected. That means we will have at least one mean is different. So continue with this one, but right now we can see significance of the difference is all different. That's the result not correct. The reason for this one is we didn't insert this Q critical value. So we need this insert this Q critical value to do the this Q values comparison. So find this value from Q table with the number of groups. So number of groups in this sample, we have 3 groups of group for columns and the degree freedom within groups for rows. We already have this one degree of freedom within groups equal to 9. So we have 3 for the columns, 9 for the rows. So you probably look down here, we have 4 sets of data, 3 sets of data, 4 sets of data, and then there's a Q table. Remember, let's click here. So we only provide this one is at alpha equal to 0.05 level. So we remember we have the column is 3, row is 9, which is 3.95. So insert this value here, 3.95. Enter. So we now have these values to show up. So we know sample A, sample B has a significant difference. So significant different, yes. And the sample B and C is not different. And the sample C and A is different. So you can see the sample A is basically different with sample B and C. B and C, it can be C, it has no different. So that's basically use this value to answer questions. In this case, from here we know sample A is significantly different with sample B and C, and from the average value we see the sample A's mean value. That's basically the pain level is much lower than sample B and C. That's the this calculation. That's basically this one, and also box plot is provided here. Continue. We do the normality test. So first we do this. Basically, I copy those data over the second sheets, and then we have sample A, B, C, and then we do residue calculation, and then I already do the probability for this one, index I 1 to 12, and then we get this value. I first get this value at the different columns. I just use this value. Remember from previous one we have the average 3.25 for group A, drug B is 7.25, and drug C is 6. So I just use this equal to this value, subtract 3.25. So drag 4 of them, give the values of this one, residue. And the second one is using this value, subtract 7.5, get this one, and then goes to this value, minus 6. We get all these values. So I use the different columns is because we calculate these values, but in the residue plots we want to sort these values, but the sorting of this value does not yield the valid data. And even I copy this data to this cell, these columns, it does not allow to sort because this associated with the equations. So what I do is we copy this value into a Word file. So you can see I already copied this in the Word file. Delete this one, and then we just paste here. And then we do the copy of this data back to the Excel, and it will treat this value as values, not from the equations. And then we do the sorting on this one. So at home, we sort this one smallest to largest, and continue with the current selection. And you can see my probability plots. Remember, I select these columns and select these columns. I do the probability plots, and this one is give us very close. So all the data points is very close to this one. There we another plots is just the. So not really quite well. We do the insert dot plots, the residue plots. So that's residue plots does not really distinguish the drug A, drug B, but drug C. But we just want to see the equal variance. So if we have 0 here, equal variance is quite good, even though this point may be a little bit far. But this probability plots shows quite well fit the near normal condition. And from box plots, we see these two is a little bit skewed. So we test those. Basically, we do the probability plots for sample A and sample B. So this is sample B. That's the basically I do the ID. These two columns again for the probability values, and then we do the sample A's probability plots, sample B's probability plots. Because we have really small data sets, it seems normal, fit the normal condition, but in fact, because the sample size is too small, this two figure does not really give us more enforce on normal distribution of that data. We don't have any more times. Just stop here. Thank you.